want to take a deep dive into controllers because there's a sense in which these are sort of the heartbeat of the MVC application. Some people have called the controller the traffic cop of MVC because it's the infrastructure that makes sure URLs get handled correctly. So the URL comes in, the controller is the one that figures out what it's supposed to do and what's supposed to go where. Controllers actually require very little infrastructural code. In fact, probably the majority of the MVC.NET framework has been written to support controllers and routing and trying to make that as automated as possible so that you don't have to write a lot of that code yourself. So when we use controllers, there's a few different things that we need to be aware of. The first thing is that controllers implement the iController interface. This is something that's present in the MVC framework. And also that the name ends with controller. Now that may seem a little silly, why does the controller name have to end with the word controller other than, well, it's a controller? But remember that MVC is predicated around convention over configuration. So by giving our controllers the last name of controller, it keeps the framework from having to store a map or a configuration file or something that maps all of our controllers. It just knows I can look in the controller folder, anything that has controller on the end that implements iController, I can just register that as a controller and I don't need some other file to map all that out for me. But it's kind of neat because anything that meets these requirements can be registered as an MVC controller, which provides a lot of flexibility if you need it. So we can write our own controllers, really, or we can even write our own little mini controllers to handle certain fringe cases. So let's talk about this iController interface. It is one of the world's most easiest interfaces to implement. It only has to implement the execute method. That's it. So if you implement this interface and you implement the execute method, whatever it is you return out of that execute method, that's what's going to come out of your controller. And that's it. The MVC infrastructure will automatically run that method as long as the URL matches what you've set up and named in that controller. What I've got here is just the default MVC application that Visual Studio creates when you select the Internet Application template when you make a new MVC project. So all of these are just default files that MVC will create for you. But what I want to do is show you how easy it can be to customize this framework by writing our own controller. I'm going to tell you up front, it's not going to be an amazing controller, but it will at least show you how easy it is to write your own. So I'm going to come over here to my controllers folder. I'm going to right-click on it, and I'm going to say Add. And notice I even have pre-built functionality to add a new controller that'll fill out a lot of code for me. But just so I can show you how easy this is, I'm just going to say Add a new class. And I'm going to call it, let's see, we'll call it Basic Controller. Remember that I do want to have the name end in controller because this is one of the ways the MVC framework knows where to register my controllers. That way I don't have to tell some file or whatever, hey, I made this new controller, so make sure you pay attention to it. It'll automatically do that. I also need to implement the iController interface. Okay. Now I'm getting this red wavy line here because it says it can't actually find this namespace because this is actually going to be in the MVC references. So what I want to do is, if you look in these MVC references, so you'll notice things like Microsoft Web Infrastructure, Microsoft Web Pages. You'll notice some of the things you're familiar with, but I also want to point out we've got System Web MVC, which is a pretty key DLL, and System Web Routing. So what I'm going to do is in my using list, I'm going to add using system.web.mvc and using system.web.routing. And now it's happy again. So we know where the iController interface is. Now the iController interface has only one method. It's the execute method, and it looks like this. public void, execute, and I get one parameter. I get a request context. In other words, when somebody types in a URL, the MVC framework generates this request context, and this has all kinds of information about the request, like what was the URL that showed up? Is it a post? Is it a GET? It shows all kinds of information about the request, and this gets passed to your controller method. So when I have this request, I can now interact with it. One of the simpler ways I can do is I can grab the HTTP context out of it, and I can do something like request context, HTTP context, response, right? The basic controller is working. I told you up front this was not going to be an extremely impressive controller, but we have it here. And so since I've followed the naming convention, and since I've implemented the iController interface, then I should be able to invoke this controller from the web application. Let's give it a shot. Let's make sure we build first. Okay, it doesn't look like I've forgotten anything. I'm going to fire up Internet Explorer, and by default it will open up the home controller, fire off its index method. And what I'm going to do is I'm just going to say basic, and it says the basic controller is working, so it went to the basic controller and it fired off the one method the basic controller has to implement. Now you'll notice what I didn't do is make action methods, which is what we're normally used to seeing on controllers. There's another class that gives us the functionality to add multiple action methods, so it's really easy to do that as well, but I just want you to see it can be very easy to customize your own controllers in an MVC application. If you've seen the iController interface, then you know it only has an execute method. But when we start dealing with MVC, a lot of times what we want is to have multiple action methods in the same controller. We want methods like index and login and those kinds of things. Well, the iController interface by itself doesn't really give us a framework for that, so that brings us to the ControllerBase class. It's an abstract class that implements iController, and it provides some useful, lightweight functionality for dealing with views and models. So a lot of the things you're used to when you open up a controller actually come from the framework provided by the ControllerBase class. So when most people make their own controllers, they don't implement iController directly. Instead, they inherit from the ControllerBase class so they can get a lot of that foundational kinds of functionality we're used to working with. So then we come to the controller class, which is an implementation of the ControllerBase. And here's some of the things it provides. It provides the mechanism for action methods. It also provides different action results, because up until this point, you've probably only seen views, but action results can actually be more than just views. They can be PDF documents, they can be streams of text, they can be binary results. The controller class also provides us filters, ways to determine exactly which action we want to call and how. So for example, if we only want an action to fire when the HTTP is posting, then that's a filter that we can get from the controller class. What I've got here is the default home controller that MVC automatically produces. And you'll notice that this does not implement iController directly, but instead it inherits from the controller class. The controller class in turn inherits from ControllerBase, and ControllerBase in turn implements the iController interface. Okay, so this is kind of the inheritance chain, or implementation chain if you prefer, as it goes down. So whenever we inherit from controller, we get a lot of pre-built functionality in these base classes, and we're implementing a base interface. Okay, so when I go to make a brand new controller, I probably don't want to follow the pattern of simply implementing the iController interface. I get a lot more functionality out of the box if I inherit directly from controller. So watch how this happens when I use the automatic interface to create a controller. I can come over here to the controllers folder and right-click on it. I can come down to Add, and right off the bat I can choose Controller, and I get this dialog box. So first of all, I have to give it a name, and notice that it's going to, by default, cause controller to be appended to the end of this. So let's say I call this Basic 2, because I'm feeling really descriptive and imaginative today. So instead of Basic Controller, this is Basic 2 Controller. I also have a few different options when it comes to what kind of controller I want to make. So an empty MVC controller is fine, especially if you've used the framework for a while and you're kind of familiar with what you want to do. But even to this day, even as much as I've built MVC applications, I'll still often choose one of these other templates just to go ahead and set up kind of a skeleton for me. Here's some of the API controllers, and I'm going to stay away from those for the time being. I'm just interested in the pure MVC controllers. But notice I can set up a controller with read-write actions and views using Entity Framework. So if you use Entity Framework as your ORM, you have a lot of automated functionality tied with the MVC framework. It can go ahead and build EF classes for me and calls all the methods and the context and everything. You can really get a web application up and running really, really quickly with a database, Entity Framework, and the MVC framework. But since I'm not using Entity Framework, at least right at this moment, I'm just going to call an MVC controller with empty read-write actions. Now, if I had used this, it would ask me what model class I was building this controller on, and it would scale out what my data context was for Entity Framework, so it could write a bunch of automated code. Since I'm not using Entity Framework, I'm just going to use empty read-write actions. And notice when it makes my Basic 2 controller, it goes ahead and inherits controller for me. So I already have this registered as a controller. It will work right out of the box. In fact, it'll work just like this. It'll work terribly because I don't have an index view and I don't have a details view, so it'll try to call views that aren't there, and then I'll probably get a resource not found exception. But I've got the skeleton all ready to go, so when I've got my Basic 2 controller firing, what do I want to happen when the index method is called? And I can put that in here. And it shows me examples of the URLs that will fire those specific methods. Okay, so you can kind of see how this works. So this would be a great method to, if I wanted to list out a bunch of products, I could do that here, maybe in the index page. And then when you click on one, I could send you to this URL and put the ID on the end. And this is where we might hit the database to get a record for that. Okay? And the same thing goes with these creates. Here I get a form, get a collection of form properties, and I can use that to create a new object and insert that into the database here, for example, or all kinds of things. There's all kinds of things we could take a look at, but what I want to draw your attention to is the fact that by inheriting directly from the controller class, it's very easy to make our own controllers and just go crazy. And all of a sudden, these are already registered as perfectly valid URLs that our web application can respond to, and I have all my options available of adding my own filters. Like here, this one will only get called in a post action. All these things come directly from the controller class. It's so easy just to make my own and put my own custom code into it. So now that we've talked some about the way controllers work and the way they're invoked, let's kind of put controller in their perspective in the MVC world map, if you will. Here's a diagram that represents the way an MVC request comes in and comes out as a response. So when the request first comes in, the first thing that kicks off is the routing engine. In other words, MVC takes in the URL from the request and any other information that might come in with the request, and then tries to make a decision about how to handle it. And so these routes are defined in the route config file. After it looks at the route and decides where it needs to go, it finds the controller name, and it uses something called the controller factory to instantiate a controller from all the different controller classes. So for example, if the URL had home for the segment where the controller name goes, it would pull up the controller factory and say, hey, give me a home controller, and that factory would build a home controller, which is the red box here in the diagram. So that controller now exists as an instantiated object, And then the action invoker kicks in. Now that I have a controller, which one of its methods am I supposed to fire? So it uses the action name that's in the URL, and it looks in the controller for that action method. That method fires. 9 times out of 10, that action method is then going to return a view, and that view then is going to get converted into HTML, which is returned as the response. So you can see the controller is right at the heart of the way the MVC pipeline processes requests, all the way from the URL to finding the right action to ultimately providing the view that comes out to the client.